This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're in Unit 7. We're talking about sum and difference formulas, which corresponds to Section 7.4 in our textbook. And we're continuing on with the Day 1 notes, looking at a couple of more examples. So for example 2, we want to find the exact value of sine of 7 pi over 12. And we touched on this in the last video. We could plug this into our calculator and get an estimated value, but using our sum and difference formulas we can get an exact value and we don't need to use our calculator. So the first thing that we need to do is we need to figure out how I can write 7 pi over 12 in terms of our special angles. So I know that 7 pi over 12, and sometimes you may have to play around until you find something that works. But 7 pi over 12, if I break this down into 3 pi over 12 plus 4 pi over 12, these are two good angles because these will both reduce into special angles. So 3 pi over 12 would be pi over 4, and 4 pi over 12 would be pi over 3. These are special angles, so I'm going to write down my coordinates here because we're going to use these in a bit. So pi over 4 is root 2 over 2 for the x and the y. And pi over 3 is 1/2 and root 3 over 2. So we'll need all of this information in a bit. So now I can rewrite sine of 7 pi over 12 as the sine of pi over 4 plus pi over 3. And then if I use my sum formula to expand this, it would be the sine of pi over 4 times the cosine of pi over 3 plus the cosine of pi over 4 times the sine of pi over 3. Right? So just when you're working out these problems, keep your formulas handy so you can refer to them so you don't make silly mistakes using a formula incorrect. So let's go ahead and find out what all of these are. The sine of pi over 4 y coordinate, root 2 over 2. Cosine pi over 3 x coordinate is 1/2. Plus cosine pi over 4 x coordinate of pi over 4 is root 2 over 2, and sine of pi over 3 is y coordinate at pi over 3, so that's root 3 over 2. Again, when we're multiplying fractions, you just multiply across the numerators and denominators. So we have root 2 over 4 plus root 6 over 4, which is just going to be root 2 plus root 6 over 4. As you work out these problems, you'll notice that a lot of the answers are similar because basically we're using the same sets of angles in all of these problems. We're using pi over 4s, pi over 3s, pi over 6s, occasionally pi's and pi's over 2's. But since we're using those same special angles over and over again, our answers are going to be similar. Alright, moving on to something a little bit different. We want to find the value of this expression without a calculator. And although it looks a little bit scary, let's work it from the inside out and pick it apart. So first what I'm going to do is I'm going to look at the sine inverse of 1. Okay, so basically what I'm looking for, since this is a sine inverse problem, I'm looking for an angle that has a y coordinate of 1, and we know it's got to be on that right half of the circle. So if we're looking at our circle here, and I know we've got to be on the right half, got to be on the right half over here. So where on this right half of the circle would we have a y coordinate of 1? Well, up here at the top at pi over 2, my coordinates are 0, 1. So there's my y coordinate of 1. So I know sine inverse pi over 2 of 1 is pi over 2. And I also want to find the cosine inverse of 1. So now we have a different part of the circle because this is cosine inverse. If you recall cosine inverse, we've got the top part of the circle. So now we're looking up here and we want to find where the x coordinate is 1. So that's going to be over here. That's 1, 0. So that's going to be 0. So basically what we're looking for here, that's going to be 0, is we're looking for the sine of pi over 2 plus 0, which basically comes down to the sine of pi over 2, which is just 1. So didn't necessarily need to use our sum and difference formulas because we just had 0 in there, but we just as easily could have, which we are going to for the next example. So we want to use right triangles to evaluate each expression. So keep in mind that this refers to some angle in a triangle or on the unit circle or on a circle, and this also refers to some angle. So a lot of times what I'll do is I'll rewrite this as cosine of alpha plus beta, or whatever variables you want to use. So for the first part here, cosine inverse of 3/5, basically what that tells us is that I have a triangle with an angle of theta, and the cosine of this angle theta is 3/5, so that would be the adjacent over the hypotenuse. And this is one of our Pythagorean triples, or you could just use the Pythagorean theorem to figure out that this third side is 4. So now I know whatever this angle theta is, I know the triangle that it is in is a 3, 4, 5 triangle. And then I have some other angle here. Remember, our inverse trig functions refer to angles. So I have another triangle here with an angle I called beta, and I know that the sine of that angle is 5 over 13. So sine is opposite over hypotenuse. This is a 5, 12, 13, or again, you could use Pythagorean theorem. So now I have these two triangles. So since I have all three sides of these two triangles, I could find whatever trig functions I wanted to find. So I've got the cosine of these two angles. That should be a minus over here. Let's fix that. And I'm going to use my sum formula to expand this. So cosine of theta minus beta is going to be cosine theta cosine beta plus sine theta sine beta. And then I'm just going to figure out what each of these are based on their triangles. So cosine of theta, cosine is adjacent over hypotenuse, so that's 3 over 5. So this whole thing is 3 over 5 times cosine beta. So now I'm going to go down to this bottom triangle, cosine adjacent over hypotenuse, so that's 12 over 13 plus sine of alpha. I'm back up at the top triangle, or sine of theta. Sine of theta is opposite over hypotenuse, so that's 4 over 5. And sine of beta, back down to the bottom triangle, sine is opposite over hypotenuse, 5 over 13. So again, I have the sum of some products here, so I'm going to multiply straight across. 3 times 12 is 36. 5 times 13, 65, plus 4 times 5 is 20. 5 times 13 is 65, and then I'll add those up. I have a common denominator. That's going to be 56 over 65. So it's kind of a long process. It's not really very difficult. The key here is understanding that the cosine inverse of 3/5 really is just talking about an angle in a triangle, and that the sine inverse of 5 over 13 is talking about another angle in a different triangle. Okay, so keep that in mind. Alright, so that's it for the day 1 videos for this section. Make sure you're working through a lot of the practice problems, and we will see you in the next video.